Lesson 1-7, Functions. A relation in which each element of the domain is paired with exactly one element of the range is called a function. A function is a relationship between the input and the output. So there's exactly one input and exactly one output. And we're going to look at a lot of examples throughout this lesson. The first thing we're going to look at is how to identify functions. So for each domain, there may only be one range in order for it to be a function. So we're looking at the domains right here. So we have -2 pairs up with -3. 0 and 3 pair up with 6, and 4 pairs up with 9. Domains can share a range, but range cannot share a domain. So if we're looking at the set of ordered pairs right here, we have 2, 1, 3, -2, 3, 1, and 2, -2. So when we create our domain and range chart and we go and we map them out, you can see that 2 pairs up with 1 and -2, but 3 also pairs up with 1 and -2. So the range is actually shared between the 2 and the 3. And so therefore, we would not identify this as a function. Pause the video to determine if the ordered pairs below are a function or not. To determine if these ordered pairs are functions, we need to create a table and then map them together. So I'm first going to write out all of my x values for my domains. So -4, -2, 0, 2, and 4. Now I'm going to write out the range values, or my y. So 1, 4, -1, 1, and 4. So again, we have this 4 that is repeating, but that's okay. So then we map them, and we say the 4 goes with the 1, the -2 goes with the 4, 0 goes with the -1, 2 goes with the 1, and because this 4 and that -2 share, I'll actually just show it this way. 4 with the 4. So now we have to determine if this is a function or not a function. And we would be able to identify this as a true function because all of them pair up with just one range. So this one is a function. Now, looking at the next set, we first want to look at our domain, which is 2, 5, 6. So we write those down, 2, 5, and 6. And then we look at our range, which is 6, 7, 9, and 10. 6, 7, 9, and 10. And we create our map. The 2 pairs up with the 6, the 5 pairs up with the 7, and now we have the 6 that pairs up with the 9 and the 10. But we've previously talked that you cannot have a domain that pairs with two range, so this answer would be not a function. When drawing graphs of functions, there's a number of steps that you have to follow. First, you have to make a table of the values, and this is where you're listing out your x and your y's in a table with your domain and range corresponding to each other. Then you need to determine the domain and the range. We know that the domain is the x value and the range is the y value. You want to write the data as a set of ordered pair with x and y, and then you want to graph those ordered pairs on a graph with your x-axis and your y-axis. Let's take a look at this example. Suppose you are filling a bird feeder with seeds. The bird feeder will hold up to 3 quarts of seed. The feeder weighs 2.3 pounds when it is empty and 13.5 pounds when it is full. So below I've made a table. In quarts I did 0, 1, 2, and 3. And so when it is empty, you know that it is 2.3 pounds, and when it is full, with 3 quarts, it is 13.5 pounds, and then the 2 numbers in between. So now we need to identify the domain. The domain here would be our x values of 0, 1, 2, and 3. And the range would be the y values, the 2.3, the 6, the 9.8, and the 13.5. So if I want to write out my coordinates, we have 0, 2.3, 1, 6, 2, 9.8, and 3, 13.5. So from here, now I can create my graph. So I have my x and my y. I'm just going to make some of the dash marks. Okay, so I just made 10 on each side. I know we're going to need a little bit more than 10 for the 13.5, but we can estimate. So our first set of ordered pairs is 0 on the x and 2.3 on the y. So we go over 0 and we go up approximately 2.3. Now we have 1 on the x, so we go over 1, and then we go up 6. About right there. And then we have over 2 and up 9.8. And then we have over 3 and up 13.5. And again, I'm just going to estimate. So now if we connect all of these, we have now graphed our function. Pause the video and graph the function below. The table shows the total enrollment in U.S. public schools. So here you have the school year, and then you have the enrollment in thousands. So I've already created the table. Now we just have to write our ordered pairs. And so we're actually going to represent the domains. Instead of using a time frame, we're just going to identify them in terms with 0, 1, 2, and 3. So for my first set, it's going to be 0, 48,560, then 1, 48,710, then 2, 48,948, and then 3, 49,091. So when we go to create our graph on the next slide, we're going to use those and we're going to plot them on the actual school year, but with the enrollment numbers up the side. And I'll show you what that looks like in just a moment. So we could create a graph like this in order to graph those ordered pairs. Again, we're going to use the actual date ranges in place of the domain 0, 1, 2, 3, but all I did was copy over those ordered pairs from the previous slide to this one. So if we want to graph our points, we first want to find 0, which we're corresponding with the 2004-2005, and 48,560. And I counted up by 250, starting at 4,800. So 560 would be approximately right here. 2005-2006 is the domain of 1, so 48,710. 2006-2007 is domain 2, 48,948. And then the last one is domain 2007, 2008, which is 49,091. So there we are with our line, and we can connect those dots if we wanted to. And that would be what our graph would look like. There's also a test that we can do to determine if a graph is a function, and it's called the vertical line test. So if no vertical line can be drawn so that it intersects the graph more than once, then the graph is a function. So if we're looking at the pictures below, for the first graph, if you draw a vertical line anywhere in this graph, it only crosses the graph one time. So therefore, this one is a function. In picture number 2, you draw a vertical line, and it actually crosses the graph twice in 2 different spots, here and here, so this one is not a function. And in this example, you could draw a vertical line anywhere, and it's not going to cross the graph but one time, so yes, this one is a function. We can also determine if an equation is a function by replacing the x value with -1, 0, 1, 2, and then solving for y. So if we look at this example here, we have -3x plus y equals 8. So if we replace the x with -1, we have -3 times -1 plus the y equals 8. So when we're doing equations, -3 times -1, 3 plus y equals 8. Then we subtract 3 from both sides to get y equals 5. So for our first set of ordered pairs, we have the x is -1, the y is 5. Then we can replace that x with a 0. So -3 times 0 plus y equals 8. And 0 times anything is 0, plus y equals 8. So our y value is 8. So this ordered pair is 0, comma, y. Our next one is replacing it with just 1. So -3 times 1 plus y equals 8. -3 times 1, -3 plus y equals 8. You just add 3 to both sides to cancel this out. So y equals 11. So your x was 1, the y was 11. And for the last example, you replace it with 2. So -3, 2 plus y equals 8. Sorry, everything's kind of running together. -3 times 2 is -6 plus 8. And then you add 6 to both sides. So 8 plus 6 is 14. So the y value here is 14. So then you have your x is 2 and your y is 14. Then you would be able to set these up in a table where your x is in the top and your y is in the bottom with the corresponding coordinates. So here's the table from the previous slide, and now we're going to graph those points to make sure that it's a function. So our first one is -1 and 5, so we go over -1, which is in the left direction, and up 5. So it's about right there. Then we go over 0 and up 8. And then we go over 1 and up 11. And again, we're just estimating here because my points only go up to 10. And then we go over 2 and up 14. And we connect our lines, and it's here. Then we would be able to do a vertical line test to make sure that this is a function, and it would be yes to a function, and that's what your graph would look like. So function values are equations that are functions and they can be written in function notation, which is like the example below. In functions, x represents the domain. So f5 tells you that you replace the x in the equation with the 5 and then solve. So for the example that we're using, fx equals negative 4x plus 7. So we're going to replace the x with a 2. So we have negative 4, and the x is 2 plus 7. So we have negative 4 times 2, which is negative 8, plus 7 is a negative 1. So this would be your final answer. Pause the video to try the examples below. Fx equals 2x minus 3. Remember that you're replacing the x with the negative 2, and then you're going to replace it again with the negative 3 plus 1. Let's take a look at the first example. So 2 times negative 2 minus 3. So we have a negative 4 minus a 3. So negative 4 minus 3 is negative 7. So that's our first answer. And then down below, we're now replacing the x with almost an equation. So you have 2, then you're replacing negative 3 plus 1 minus 3. Order of operations, you always do what's in the parentheses first. So negative 3 plus 1 is a negative 2 minus 3. And so, again, we get the same answer. Nonlinear functions are when the equation contains exponents, and this will not produce a graph that is in a line. So the graph for a nonlinear function is not a line. So we do the same thing as we did with the functions before. You replace the variable for whatever the function tells you. So in this case, the equation is ht equals 2h to the third. But then it tells us that we need to replace the h with a negative 5. So 2 times negative 5 to the third, which means negative 5 times negative 5. So that's positive 25 times negative 5, which is going to be a negative 125. So then you take the negative 125 and you multiply it by 2 to get your negative 250. Pause the video to try the examples below. Remember that you're replacing the variable with the function that it's given. Example number 1, so gx equals x minus 2x squared. Again, it's nonlinear because it's including exponents. The x is going to be negative 1. So we write it as negative 1 minus 2 times negative 1 squared. So we're going to do our exponents first. So we leave the negative 1 and the minus 2. Negative 1 times negative 1 is 1. So we have negative 1 minus negative 2. So our answer is a negative 3. Now for the next one, you're actually going to replace the x with a 3y. So 3y minus 2, 3y squared. So now you go through and you square your parentheses. So 3y minus 2, 3y squared will be written as 9y squared because you squared everything. Now you distribute in your 2, so your final answer is actually 3y minus 18y squared. And you're not able to combine any terms here because your variables are different. Pause the video to complete the lesson review. All that you're doing here is you're determining whether each relation is a function. So there's an example of a mapping, there's an example of a table, and there's an example of a graph.